Welcome. I'm Michael Cole, the Chief Technology Officer for the Federal Civilian Division here at GDIT. Here at GDIT, we're privileged to support some of the greatest missions of our country. The Federal Aviation Administration is one of those agencies that we get to support. The FAA is charged with protecting the airspace of our country, making sure that travelers get from point A to point B, making sure our packages and goods are delivered on time, all of which impacts the economy of our nation. Today, I'm joined by a couple of GDIT colleagues to talk about the modernization journey that the FAA has started on. Michael, if you could introduce yourself.
Thanks, Michael. I'm Mike Hawthorne. I am a Director for Aviation and Transportation here at GDIT.
Jay?
I'm Jay Olsen. I lead our Mission Software Center of Excellence for our corporate CTO office here at GDIT.
So as we think about modernization, the word automation always comes into play. So Michael, automation is not new at the FAA.
Correct.
It's something they've been doing for years.
Correct.
So as a start, could you kind of lay the groundwork of where automation is with the FAA, but also talk about how AI can actually further enhance that automation?
So let me start by laying some groundwork for the complexity that you talked about, right? So the FAA's Air Traffic Organization, they manage about 30 million square miles of airspace. There's about 45,000 flights a day. There's 2.9 million human beings on those flights. It's a massive mission. You talked about the economy. Aviation, commercial aviation alone drives 5% of our gross domestic product here in the United States. So it's an imperative to make sure that it's safe and it's efficient, right? So automation is not new, as you mentioned. The FAA has been using automation for years. But the aviation industry has considered itself to be a pioneer in the automation world. The institution of the autopilot some 80 years ago was some of the first automation known in the technology realm here in the US and the world. So again, automation is not new. FAA has been using canned algorithms and historical data to make predictions about flight paths, to make predictions about where conflicts are and how to resolve them, to organize the airspace most efficiently it could possibly be organized. But it's canned information. And the algorithms are honed over time, but they're honed over time and then redeployed and then they're used again. The institution of artificial intelligence and machine learning for me is an absolute groundbreaker because it allows these systems to not just rely on occasional updates based upon the collection of more data. It allows these systems to learn as they go and hone those recommendations that they make, right? So we're not talking about replacing air traffic controllers with AI. We're not talking about replacing pilots with AI. What we're talking about is making the systems and the platforms that they use better so that they can do their jobs better. And then aside from that, and Jay will talk about this in a second, AI allows us to build these capabilities and platforms and systems better as well. So it allows us to build them better, deploy them better, and then provide better use for the people who use them.
Yeah, I'm excited about how AI can impact this critical industry. Being able to get to those decisions faster, right? Making sure that the information you have at your hand is actionable and actually can be used to improve flight. As a traveler, it's important that I get where I'm going and I get there quickly, right? Because we all travel on a timeline.
100%.
So it's really important.
Yep.
So Jay, Mike just talked about automation and artificial intelligence and the value that that's going to provide to the FAA. One of the things that we know is that you can't just move something without using AI-assisted development and AI-assisted testing. Could you go into a little bit of detail about how GDIT thinks about that?
Absolutely, Mike. When we think about modernization here at GDIT right now, we are actively applying AI-assisted software development, we call it, across the full software lifecycle. So that runs the gamut from initial requirements decomposition, as we call it, where we're moving what we call from epics to features to user stories, moving into obviously code generation and code suggestions for the developers to help drive them and accelerate their development efforts, moving into testing, and I'm going to come back to testing in a second, moving into security vulnerability identification and resolution, right? A really essential part, and AI is very effective at that for us. And then finally, things like deployment automation. How do we automate our deployment so we can do what we call continuous integration and delivery and get to the point where we can deploy daily in a much faster cycle, typically which a much smaller volume of features, so we can move very quickly and respond to our customers' missions. Coming back to testing for a second, we typically take, especially for critical, safety critical systems like we're dealing with here, a layered testing approach. So we've got our individual developer tests, unit tests. we often are fans of applying test-driven development. We leverage AI to help us generate our tests and actually help resolve testing issues as well. And then we typically move into integration tests where we're making sure that the systems and all their not only internal components but external interfaces are working properly. And finally, typically what we call end-to-end testing, which has much more of an end-user mission focus to it. We're ensuring the mission users are seeing exactly what they expect to see as an outcome from each component. And AI, again, helps us drive that and automate that. The other point that I would make about safety critical systems like this is there's always a human in the middle of all of those steps that I described. So our developers, think of it as the AI sitting on the shoulder of the developer, but the developer and the architect always have control over what the ultimate output and ultimately what we're deploying. So some critical components of how we're leveraging AI today.
Yeah, AI is like a force multiplier in the development world, which is pretty cool. But when you think about the FAA and the critical nature of what it does, it's a system that cannot fail. Like we've seen that in times where if it goes down, people can't travel, things happen, and it impacts all of us, right? So when we think about introducing AI, and Jay, I'm going to ask you this question, when we think about introducing AI, we have to do it in a way that's smart, that's safe, right? So when you think about the new technologies around model-based system engineering and being able to simulate applications, simulate infrastructure so that when you implement these new technologies, the system is going to work because you've already tested it. You've run it 1,000 times and you know it's going to work. Could you go into a little bit of detail about the MBSE solution and approaches that we have here at GDIT?
Yeah, Mike, absolutely. So we've had success recently leveraging what we call our digital engineering environment solution, which is a model-based system engineering approach for the Air Force's ground-based strategic deterrent program.
That's a mouthful.
It's a mouthful, and think about these are critical weapon systems in defense of the United States, right? And so what we do is apply a consolidation of our engineering talents, our something we call navigable relationships, what we call authoritative sources of truth, and link those things through digital threads to make sure that the critical customer requirements are always aligned with our development and engineering processes, that they're aligned with the artifacts that we produce, and that they're aligned with things like cybersecurity controls to make sure security is inherent in everything that we build. And then we're able to use those digital threads to create business processes that we can validate virtually as opposed to actually having to touch a cyber-physical artifact. So it enables us to do modeling and simulation and understand the implications and impacts of changes we might make on a virtual system without having to touch the physical system. On that particular program, we were able to reduce what we call cycle time, the time that a requirement is identified, to a change being into production within 4 days, which was a really dramatic turnaround time to get capabilities fielded. The other improvement, I think we had an 80% improvement in the time it takes us to provision new environments in which to do this work. So if you think about that sort of approach for the FAA and the FAA's mission critical systems, very similar, right? We also can implement things around what we call reverse engineering. So as we're looking to modernize older systems, we use the digital engineering capability to understand all of the legacy artifacts, understand how they're linked to the actual physical systems, weapon systems, components, et cetera, to make sure there's no gaps in any of the requirements or the testing processes.
That's impressive. And knowing that the FAA is going through a pretty critical modernization right now with a pretty aggressive timeline. Listen to you talk about the time savings of getting there, right? Because when you deploy, it's done right the first time. You don't have to worry about a rewrite or a recode. You're doing that in those simulation environments. I mean, I'm gonna throw you a softball in this sense. Like you used to be at the FAA. How exciting is this technology?
It's ridiculously exciting. So modeling and simulation is also not new, right, to aviation.
Right.
But the ability to model and simulate big picture infrastructure, right, and how it interacts with the pieces and parts, how it interacts with the policies, right? We don't spend a lot of time talking about policies. You mentioned cyber, but every cool problem has 3 components: technology, operations, and policy, right?
Right.
So the technology piece, I always say, is the easy part. The operations piece, forever, you get in a lab and you run it through a massive test and evaluation program that takes weeks, years, right, in some cases, because it's crazy complex. We hear about the technology of the air traffic control system is outdated, and And there's a lot of conversation around that right now, and it's not untrue, right? But it's a massively complex system with tens of thousands of sensors and systems and subsystems talking to one another, and the human beings that make it all dance, right? So the ability to use technology like this, use digital engineering to play out all these scenarios and to make sure that the policy pieces interact as you think they're going to with the technology and the operation pieces, and know that before you get to the field. Again, that's a sea change with how we're deploying things. And that's a lot of the time. There's a lot of aggressive timelines right now.
Yeah.
And there's a lot of conversations around, well, it's a procurement problem and so forth. Well, all these things play in. The ability to know that you got it right and that you can transition to it properly and that you can do it safely and efficiently, that's where the time savings is going to come in. And that's where this capability that you guys have built is really going to just be awesome.
Yeah, and I think what's interesting, as we talk about, you both have mentioned modernizing the underlying legacy infrastructure, right? I think we'd be remiss if we didn't talk about cloud in that viewpoint a little bit, right? Because the way I look at cloud is all clouds are hybrid. So it's like very few agencies are 100% in the cloud or 100% on-prem. So figuring out that balance, but I know cloud is not new to the FAA either. They've really been pretty on the edge of new technologies over the lifespan that I've known them, and I'm sure while you were working there. So can you just talk a little about where the FAA is in their cloud journey?
Certainly, and it's really hard during conversations like this to avoid the bad pun between clouds and airplanes, right? It happens, right? The sky's the limit, all that stuff. So yeah, the FAA started its cloud journey 10 years ago, a little bit more than 10 years ago. And along with the rest of the government, right? And the baby steps there for a lot of the government were, let's get the email over in the cloud, right? And let's do some of these administrative things. The FAA took a forward lean. And GDIT is actually the first and current provider for the FAA Cloud Services program. And they've hundreds of accounts, hundreds of applications, and they've really done a good job of leaning into the technology. The next step is to kind of move out of the mission support area, right? So most of the cloud work right now going on in FAA, and it's wonderful, is in the mission support area. And so now it's time to figure out how to shift pieces of the National Airspace System to cloud. You mentioned hybrid. That's the perfect scenario, right? A lot of the conversation around that is just basically convincing lifelong technologists and solution architects and technicians that cloud is not scary, right? So cloud is the next step in terms of infrastructure. So we haven't spoken yet, but there's part of the other issue that the FAA is dealing with is that the infrastructure that it's been acquiring and operating and maintaining for years is past its useful life.
Right.
And so the government ends up with what I call racks in the basement, full of technology, right, that it bought, that it maintains, that the industry simply can't support anymore. Cloud allows the government, the FAA in particular, to stop buying racks of servers and putting them in the basement. Right? You're not going to shift the entire paradigm to, industry cloud run capabilities for the National Airspace System. There will be a hybrid component, but the fact is that cloud not only is not scary, it actually works better than the racks in the basement scenario does. Whether you're talking about availability, resiliency, in many cases security, right? Cloud can do a lot of what some of the naysayers were pretty sure it couldn't do as recently as just a couple of years ago. So it has a really big role in the NAS. Last piece is that there's a big push as part of the brand new air traffic control system that's the conversation that's going on right now, where we talk about a thing called a common automation platform. We've been talking about that for 30 years, right? And it's built on the idea that you shouldn't have to own and operate and configuration manage, right? A different set of infrastructure with different types of software and different types of applications for different types of air traffic controllers. That's all very valid. But the conversation's been mostly focused on the tools and the glass and what the controllers use. It's much more than that. Cloud allows you to have a common automation platform to run the system. Everything from traffic flow to arrival departure. Common platform where you're moving common data, you're governing it in a common way, you're running it on commonly developed and managed applications. And so there was no feasible way to do that before cloud, because you couldn't buy just one piece of infrastructure that could meet all those individual needs. So now as you try to converge the needs and converge the way you do air traffic control, having that cloud as the common automation platform upon which everything is going to be built is finally, after 3 decades, going to be the enabler to do that.
Yeah, and I think, what you just said about cloud and it being dynamic in its nature, right? I mean, a lot of these companies are always focused on what's next. That's one great thing about cloud service providers, right? They're always kind of future proofing their services, right? So it's great that we can do that. We could take advantage of that. And Jay, you talked about modernizing applications and moving applications when we were talking about model-based engineering just recently. But it's not a lift and shift model, right? It's not just pick up an application and move it to a new cloud environment, because you're not taking advantage of all these cool new features that are in the cloud. So could you spend a little bit of time about the approach and how moving to the cloud allows you to take advantage of these new capabilities?
Yeah, absolutely, Mike. Like when we're looking and assessing what a target to-be state is optimal, we always start, right, with the critical mission outcomes and drivers, right? Separate the technology from those decisions initially. And then both of you touched on the hybrid nature, and almost always these large-scale modernizations end up having a hybrid element to them. But we'll consider things like, does it make sense just to rehost an application that works somewhat effectively today? Do we need to refactor a legacy application where the core elements of the system will likely remain similar, but we're just doing kind of a coding refactoring level exercise? More typically, to your point about taking full advantage of modern cloud services, we really want to consider re-architecting in a way that makes the most sense for the agency, right? And we often see hybrid elements where we'll have classified customers, for example, where they may have to keep their data on premise and their databases on premise, but the core applications can be containerized and run very effectively in the cloud. So that's a very common model that we'll see as an example.
Right.
And you can have other components that can be cloud native. An example of that for a couple of different systems we built recently, we developed what we called, another mouthful, but event-driven architecture-based systems. So basically think of it as complex workflow systems, and those tend to be very effective as cloud native services. They can scale very easily. We can build in what we call perforation if we need to stop a certain process. Very easy to do that. So we very much take a kind of best fit architecture for the mission problem at hand.
Yeah, and I think that's where we excel, right? Is we're mission aligned partners with our customers, right? We're not bringing technology for technology's sake. We're bringing purpose fit technology to drive that forward. And listening to you talk about FAA and these technologies, I'm pretty excited that we're able to provide that to the FAA. And I really feel great that these technologies exist to help the FAA actually modernize and move forward to continue to provide the safety that we need as we travel and to protect our economy as well. Michael, Jay just talked about how we re-architect to move to the cloud, right? And one of the approaches there is to actually get away from the large monolithic applications that exist in the environments today. So how do you think the FAA can look at that to modernize their systems?
Well, and that's one of the complexities that we've been talking about, is there are some of the automation systems that we've been discussing that are in use today have 3-4 million lines of code, right? And so as you go through the process of updating and modernizing, right, with that one giant code set, regression testing, right, and making sure that you didn't break something old when you put in something new becomes a problem. And it takes a lot of time. And they're very good at it, right? The community is very good at making that happen, but it does take a lot of time. And so it's very exciting from an industry perspective to talk about containers, right, and virtualization and microservices, because you can break these things up, and when it comes time to change something, whether you're changing it to improve it or to fix it, you can get out the door quicker. And using some of the tools we've been talking about here today, you get out the door quicker to make that happen than you would be able to if you had to turn around and figure out what an update is to 3 million lines of code.
Yeah, you don't have to retest everything. You don't have to rewrite everything.
Correct.
You're just writing that one smaller component, which definitely speeds time to delivery of those new capabilities. So that's a pretty exciting area as well.
Yes, sir.
Thank you for this conversation. It was really a great conversation. For more content like this, visit gdit.com/perspectives.